did mine off yesterday.
She showed me the picture behind her. That's what I was like the first time I got my eyelashes done. But I had a really good reaction to it. So
All the way there, because I got one like this. And so when I went in, she
Okay, 8-4. Sorry I didn't include the comment on yours. We're looking at polar coordinates. So it's a little funny. He says, I don't think this is what the professor meant by polar coordinates. Polar coordinates is another one of those things where it's not that it's really challenging math, it's just that you're just not comfortable. You never, it's like, is this the first time you've ever heard polar coordinates? Possibly. Okay, so it's not that it's challenging, it's just that you're not used to working with them. So just be prepared to practice it, to remember what to do. First, let's look at graphing them. Did I get the answers? No, they're all, okay. Okay, good. So, first of all, the idea behind a polar coordinate is what traditionally is your x, y coordinate is now your radius theta coordinate. So this is helpful right here if you have a highlighter or if you just want to box it in with a colored pen, something to draw your attention to it. And then the way that you plot polar coordinates is fast backwards from what you're used to. You're used to, the first number is right or left, the second number is up or down. So what I want you to do is to take your pencil, draw an arrow to the theta, and make a note, find first. So you find your rotation first. You need to know, basically, think of it as a spinner on like a twister game, with the spinner. So you have to find your rotation first. Then draw an arrow to the R and make a note that you walk. Now this is important. You walk out if it's positive, or you walk back if it's negative. So I put right next to it a little plus sign to say that you're walking out if it's positive. If it's a negative R, then you're walking backwards. Okay? Couple more vocab words here. What you're used to calling the origin is now called the pole. So if I say from the pole, I'm talking about from the very center of the grid. And what you're used to calling the x-axis is now called the polar axis. Okay? Now, if you need more explanation of how to graph it, I copied the directions on how to graph it right here. But if you wrote this down, then you can see like the Cliff Notes version. So let's look at this picture because there's a ton of them graphed on here. Let's just draw your attention to, there we go. Go to A. Just focus your eyes here. You don't have to box it in or anything. Focus your eyes there. So if I said to graph 4, 60, so from the pole, you would rotate to 60 degrees, right? Then, and I said that you're graphing, so we know we're going this way. Let's draw it correctly. We know we're going this way, correct? Because I said 60. How do you know how far out to walk or backwards? It depends on that first number. It's a positive 4. That means you're going to walk in the direction when you rotated, where your spinner landed. And look, it's 1, 2, 3, 4. You see that? So you're just counting the rings. Let me take that off and then show you another one. All right, let's find B. B is 3 pi, 3 comma pi. So remember, rotate first. Pi means 180, right? So that tells me that I'm along this lines, correct? 180. Now the reason I have this extended this way is in case it was a negative, like walk backwards. It's a what? Positive 3. So you literally count the rings. So 1, 2, 3. You see that?
Why are you doing what?
Because the pi, you've got to imagine a spinner. Like, think of the twister spinner.
Okay, I'm not looking at my.
Yeah, think of a spinner rotating, like a terminal, a clock hand, if you will. So it's rotating to pi, and then that lets me know, okay, so if the next number is positive, I'm going to go that way. But if it's negative, then I just go in reverse, which is why I highlighted the back side of it. All right, let's look at C. C is right here. Okay, perfect. Well, the angle's negative. Okay, so negative 30. That tells me start on the initial side. This would be 30, right? Okay, but it's negative 30, so I'm going to go this way, correct? Y'all with me? Okay, so from here, I'm going to say to myself, negative 30, and then it says 2. So from the pole, I'm going to walk in the direction that my spinner would have landed because it was a positive 2. So 1, 2. Yes? Let's do D. Where is it? 390. Okay, so 5 comma 390. 390 means I'm rotating all the way and then what? 30, right? Okay, so my spinner would rotate all the way, which is irrelevant, and then it would land at 30. It's 5, so you would count toward the direction that your spinner would land because it's positive. 1, 2, 3, 4, 5. It's so simple, it's almost challenging because you're just not used to polar coordinates. And I'll be honest, this is probably the only time you're going to see. Let's go to E. Can we get a negative? Yeah, we can. How does that feel? It says 3 comma 210, negative 3. Oh, gotcha. Yeah. Okay. So look right here. Focus on this one. So 210, so the spinner would open up. This is 90, this is 180, 210, right here. So that would tell me I'm going that direction. If it's a positive number, it's positive 3. So I'm going to count 1, 2, 3. Now look at the one underneath it. It says negative 3 comma 30. Watch this. Let me change colors. So rotate to 30, so initial side to 30, right? Initial side to 30, so there's 30, but it's a negative 3, which means don't go in the direction that the spinner landed, go directly behind it, 3 spots. So I go 1, 2, and I land in the same spot. You see that? So if the R is negative, it's telling you once you land your spinner, then you're going to go directly in the opposite direction. So as far as putting on your paper, because they're all on here, you could color coordinate this and put this on there. If you have two different color highlighters, you can color coordinate and put that on there, or you can take your pencil And you could draw attention to, look right here at F. They've shown you F has 3 possible polar coordinates, and they all land in the same spot. So let's just wrap our mind around it. So 285, and then count out 4. So that's 4, 285. Or 285 is only 75 degrees from 360, right? So they're saying, or it could be negative 75 that you rotate, but then still count out 4. That would land you right there. Then this is saying, or conversely, change highlighters. Watch where this goes. This is the hard part, is trying to find it. Get that. Is that a straight line or did I curve? That's straight. Okay. So they're saying, or conversely, rotate 105. So I could rotate 105. This is where my spinner would land. But then I could go in reverse -4. So 1, 2, 3, 4, and I still land there. So there's a lot of different ways to, get any given polar coordinate. It all depends on the rotation and the direction of R. Let's practice. Go to the next slide and plot the polar coordinates that you see there. Now, when you get to E and F, you're going to notice they're in radians. What would be the smart thing to do there before you try to graph that? Yeah, I would convert it to degrees. So like 3 pi over 2 is actually 270 degrees, and pi over 3 is actually 60 degrees. So I'm going to go back to this slide so you can look up it as you need to. But I want you to plot all of those. You can also see where mine's counted out, because I think yours only stops at, it stops at 75. So remember, look at the angle first, rotate the spinner, imagine where it would land, and then move along the spinner if R is positive, move behind the spinner, imagine like the extension behind it where it would go, and move along it if it's negative. Did you get those? B was probably awkward. You would rotate 10 degrees, but then R is 0, which means don't move. Right? Don't move off the pole. If R is 0, then that means you're plotting it right there on the pole. It doesn't matter the rotation that you turn. Oh, G was my extra. Ignore G.